the end of the first week in July 2025, we went from hearing about the latest infrared innovations to pondering the question of what do we do when an asteroid threatens Earth, before learning about space conditions causing gum disease and bone loss. Let's take you on a deep dive. Before we get into the stories of the week, Gilmour Space is struggling with wind. Not the stinky kind after a big breakfast of beans, but the upper-level steering kind that can knock your orbital rocket off course. They've had to delay Ares 1's maiden flight again until a no earlier than target of July 16 as at recording. Good luck, Gilmour. A new filter for infrared light could see scanning and screening technology tumble in price and size. Built on nanotechnology, the new heat-tunable filter promises handheld, robust technology to replace current desktop infrared spectroscopy setups that are bulky, heavy, and cost anywhere from $10,000 to up to more than $100,000. Because it's built on silicon technology, its manufacture can be scaled, with the potential to push costs below $1 per filter, its developers said. The research has been published in Laser and Photonics Reviews. Spectroscopy relies on spreading the light source into a spectrum, which is conventionally done with a grating or prism to spread the infrared light. Different parts of the spectrum are sent into the sample by tilting the grating back and forth. For robustness, the transformative Meta Optics team at the ARC Centre of Excellence instead opted for a non-moving component to select specific parts of the infrared spectrum in the form of a bandpass filter. Drawing on other research within TMOS that had used heating to vary component behaviour, they devised a filter with temperature-dependent bandpass wavelengths. The great thing about it is that it is very stable and reversible, said Ben Russell, PhD student in TMOS. He then created prototypes of both by carefully etching the pattern into an off-the-shelf silicon-on-sapphire wafer, which needed a few repeats as he initially underestimated the etching rate. Sure enough, the finished prototype behaved as modelled, displaying an inner wavelength shift of 80 nanometers across the standard operating temperatures from 25 Celsius to 420 Celsius. More extreme heating and cooling to cryogenic temperatures extended this to 140 nanometers, although these extremes are unlikely to be of practical use in the future. With stable temperature tuning achieved, the team tested the spectroscopic capabilities of the filter on a number of everyday items, for example, successfully measuring polyimide tape and a zinc selenide window. They were also pleased to be able to easily distinguish between two clear recyclable plastics of different composition, LDPE and PET. As NASA prepares to send astronauts back to the moon for the first time in over 50 years, new research from the University of Technology, Sydney, has found that lunar dust is less harmful to human lung cells than previously feared, and significantly less toxic than common Earth-based air pollutants. Lead researcher and UTS PhD candidate Michaela B. Smith investigated the impact of the most accurate new generation lunar dust simulants on human lung cells in the lab. She compared the effects to those of airborne particulate matter collected from a busy street in Sydney. I knew this already. The research focused on fine dust particles of less than 2.5 micrometers, which are small enough to bypass the body's natural defences and penetrate deep into the lower airways of the lung. The study used two different types of lung cells, representing the bronchial and alveolar regions of the lung. Results showed that earth dust induced a greater inflammatory response and was more toxic to the cells than the lunar dust simulants. The paper suggests the primary mechanism of toxicity from lunar dust is mechanical damage caused by the particles' irregular shape and rough edges as they are internalized by cells. Crucially, the lunar simulants did not trigger significant oxidative stress, a key chemical damage pathway often associated with fine particle toxicity. The health of astronauts was a concern after the Apollo missions, where crew members experienced respiratory issues. And while the findings reduce a critical risk factor, NASA is still taking the threat of dust exposure seriously. Smith, who recently visited the NASA Johnson Space Center in Houston, saw new engineering solutions firsthand. One of the key changes, she noted, was the way astronauts manoeuvre in and out of rovers, with the spacesuits never coming inside the cabin, preventing dust from contaminating the internal area. The researchers paved the way for Smith's current PhD work, which investigates the next frontier of space health, the effect of microgravity on lung function. A new Swinburne research paper delves into the ethical, legal and social issues involved in asteroid mining and planetary defence. It highlights the need for a framework or governing body to be established to protect civilization. Now, this isn't a new issue, but one that continues to plague the world, with no clear mandates for who should act in the interest of protecting the planet and our lives, says lead author, Swinburne bioethicist expert Dr. Evie Kendall. Dr. Kendall points to NASA's Double Asteroid Redirection Test mission, a collaboration with private company SpaceX. DART crashed into the Didymos asteroid in September 2022, successfully altering its trajectory. While most asteroids and comets burn up in the atmosphere on their way through Earth, the larger ones like 2024 YR4 could cause significant damage and even global catastrophes. And while the UN-endorsed Space Mission Planning Advisory Group is the likely front runner in tackling a crisis, recent geopolitical events make it unlikely an immediate coordinated response would be achieved. Therefore, frameworks and governing bodies need to be developed now in order to prepare and protect for the future, Dr. Kendall says. Interesting to note, the 2021 comedy film Don't Look Up also explores a hypothetical scenario in which a planetary defence action is undermined so a private company can mine the valuable comet instead. As long-duration space travel becomes a real possibility, including for journeys to Mars and even the Moon, scientists are looking more closely at how space conditions affect health. A new study in mice has found living in zero gravity can lead to periodontitis, a common and serious condition where the gums become inflamed and the bone that supports teeth starts to break down, eventually leading to tooth loss. Scientists from the UAE confirmed their findings in the study published in the Journal of Periodontal Research, in which they try to understand how simulated microgravity, the near weightless environment astronauts experience in space, might influence the development and severity of the gum disease. The study, according to lead author Zahi Badran, University of Saraj's Professor of Periodontology, has found that mice exposed to simulated microgravity showed much worse gum inflammation and bone loss compared to mice with induced periodontitis on the ground. They had higher levels of disease markers, more severe tissue damage, and more immune cells in the affected areas. As space travel becomes a real possibility for longer missions, including journeys to Mars, as I said, scientists are looking more closely at how space conditions affect human health. However, the authors maintain that one area that's been less studied is oral health and diseases in microgravity, especially gum disease. The authors see their study as a harbinger of a new line of multidisciplinary research on oral health and disease in microgravity that'll shed more light on space medicine in general. They do also concede the limitations of their study, as its findings are based on a relatively small sample size. However, they emphasise its robustness due to the use of the HLU model to simulate microgravity, in which offers valuable insights into disease progression under space-like conditions. A powerful new telescope expected to unlock deep mysteries of the cosmos and our place within it has released its first images. For the first time, astronomers will be able to image the entire southern sky in exquisite detail every few nights, which is expected to impact nearly every area of optical astronomy and make new discoveries. Australian scientists and data experts played an important part in making the telescope project a reality. Astronomers expect collect 10 million daily alerts that objects have either changed in brightness or in position, some of which will be discoveries of new phenomena. Science lead for the Australian collaboration, University of Melbourne Professor Rachel Webster, said the US-led Vera C. Rubin Observatory, with its giant 8-metre mirror, named after the pioneering American astronomer who first measured dark matter around galaxies, will reach into new corners of our universe far beyond where modern telescopes have seen before. The scientific program enabled by the telescope will impact nearly every area of optical astronomy, from dark matter and dark energy, which tell us how our universe evolved, to the supermassive black holes in the cores of galaxies. The highly collaborative international initiative brings together world-leading astrophysicists, data experts, and pioneering new technology, because while existing telescopes image very small areas of sky at one time, the fully automated Vera C. Rubin Observatory's telescope captures observations of the southern sky every 3 nights in 6 different filters, thanks to its massive digital camera, the largest in astronomical history. The camera alone weighs 3 tons, contains 3 lenses, with the largest more than 1.5 metres, and has a sensor with 3.2 billion pixels. For comparison, the latest iPhone has a sensor with 48 million pixels. Just incredible. Daily science and space stories with an Aussie flair, plus a deep dive into the science or space headline of the week, and the occasional science fiction podcast. Like, follow, and subscribe for more. Membership available to help us do more. The Trek.zone/support. This is Trek Zones, Talking Science.